All right, well, we'll get started here and let people roll in at their leisure. My name is Matthew Watkins. I am the chair of the Sustainability Commission here in Rosslands, and I'm part of the Energy Task Force that was responsible for putting together tonight's talk, and that includes Margot Lohr and Ken Holmes. I'd like to start by acknowledging that we're hosting this event from the traditional territories of the Sinax, the Salix, the Silkwepum, and the Tunahas people. Tonight, we're going to be covering insulation and windows in home energy retrofits. So if you haven't been with us before, this is part of a 6-part series looking at home energy retrofits. Our next talk is going to be March 9th, and that's going to be covering heat pumps, which is a popular topic. We're getting a lot of people interested in that. That's going to be hosted by us, but it's going to be covered by Better Homes BC. So there's going to be a subject matter expert coming in and talking about that, and should be a great talk. And then our final talk of the series is going to be on March 23rd, and we're going to do a deep dive into a local deep energy retrofit and try to sort of pull all the components of the different things we've been talking about through this series together in sort of one clear example of what you can do when you put your mind to it. Our contact information is there. If you have any comments, questions, concerns, feedback, don't hesitate to send it our way. This is our first run through the series, and we're trying to refine them for the future. So the more information you give us, the better we can refine it to meet your needs. So tonight's talk, I'm going to start off by going over some questions that arose in the last talk regarding ventilation systems during forest fire season, which is becoming more of an issue here in Rosslands. And then we're going to talk about insulation and windows, and we're going to finish up with the Q&A. I was hoping Ken was going to make it, but I don't see him here. So I'm going to be the only, well, all of us will participate in the Q&A. We'll open it up for discussion. But we don't have any subject matter experts, only subject matter enthusiasts tonight. So if there are questions that come up, we can track them down and get back to you. So heat recovery ventilators in forest fire season. So the concern came up in the last talk that there were homeowners that were turning off their heat recovery ventilators during forest fire season because they were finding that air quality in their home was deteriorating. Heat recovery ventilators bring air in from outside and exchange it with the air inside and send it out. So some people were suggesting they turn off their HRVs. In HRV training, it's very clear that this is sort of the last resort. It's not something you want to be doing. So there's a few steps that you can take before you get to that point. So the first thing to do is to check the filters in your HRV unit. Different quality HRVs might have different filtration capacities. The higher end ones definitely will take a MERV 13, and that's usually the highest filtration that you can put into the unit itself. The second step, if after you do that, you still find air quality inside is down, you can install an auxiliary filtration system onto your HRV, and this basically allows you to put in more filters. So with these systems, you can put in MERV 15s, activated carbon filters, all the way up to HEPA filters. You can also install or have completely auxiliary filtration systems in your home, that sit in your living room or your kitchen, that can help filter the air as well. If you don't want to install, if the retrofit into your HRV is too complex to do. If that is still not getting your air quality up, the final step is to look at turning down your HRV. And basically what this is doing is reducing the number of air exchanges that is pulling from outside into your home. Most HRVs you can put into a recirculation mode. So it's still circulating interior air through the same ductwork and running it through the HRV. And this way you're at least filtering the interior air. So any contaminants that you're producing inside can be filtered and then put back into the room. There are some real concerns with turning off your HRV. If your house is airtight, which we're hoping you're seeking to have it anyway, depressurization becomes a real concern. So as you have exhaust fans going, you're pulling air out of your house, your HRV is not running, you've got air that wants to come in. So it creates a couple problems. One, it can create backdraft in exhaust systems. So your furnace isn't an issue in the summer, but if you have a gas hot water heater, depressurization can actually reduce the flow of the stack and bring in CO into your house, which can be deadly. It is a real concern. People die of this. Another concern is that through depressurization, you're going to be pulling air through your envelope. So you're going to get contaminant matter that's in your envelope into your airspace, which is another concern to think about. If you are turning off your HRV, it's highly recommended that you get an air quality monitor, particularly for CO2. So turning off your HRV, you want one of these on hand, and you want to be checking it regularly, and you want to be turning on your HRV when you can. So if there's periods of the day where the air quality is the best, turn on your HRV again to pull in air from outside, refresh your air indoors, and then you can put it back into circulation mode. But it should be understood that turning off your HRV and turning into recirculation mode does have some serious concerns, and homeowners should be aware of those if that's the approach, if they're forced to go that far, depending on how bad the air quality is. All right, so going into insulation retrofits. So I've gotten some feedback that I've been diving a little bit deep into the weeds on some of these topics. So I'm going to try and do a bit of a lighter touch tonight, but I just wanted to let everybody know up front that the topics tonight are very well covered in a number of provincial and federal documents and resources. They're super user-friendly, got lots of images, lots of easy explanations. So if I don't go into something deep enough, or if you miss something, these documents are a great resource, and I'll send these out to everybody as part of a package after the talk, probably next week. So why do we care about insulation? Well, we care about insulation primarily because of heat loss. So this graph is an interesting one that shows heat loss from different components within your thermal envelope. So you have your walls, your roof, your floor, your windows, your door, and your ventilation system. And then it also shows the heat gain, so how you're making up for that heat loss. And it shows that across different performances of homes, essentially. So walls make up a significant amount of this. But naturally, the largest surface area of your home is your walls. Your roof and floor are the next highest surface areas, but roof being on top, hot air rising, being exposed to air is the next area of great loss. And then the floors and your windows is a significant factor, windows and doors, and your ventilation system. You can see how the heating decreases as their home performance increases. You can see this great reduction in heating needs, and basically you get to a passive house where the vast majority of the heat is gained through solar and through internal functions of the home, and you have auxiliary heating systems making up just a small fraction of the difference. So the first thing when we talk about insulation that comes up is R value, and R value is basically a measure of a material's resistance to conductive flow of heat. And this is a table that shows a bunch of the most available and popular insulations that are used in retrofits. And the R value is that thermal resistance per inch. So you can see that there's a very big difference here from some of your foams down at the bottom, up in the sixes, down to fiberglass in your attic or cellulose blown in cellulose, which can be a lot lower. Understanding these R values is important. The relative R values of these different installations is important when you're thinking about their application, because in certain spots, volume won't be a concern. So if you think about your attic, you can often stack insulation as deep as you want, and so you don't need a really hard R value per inch, because you can put a lot of inches in. But then there are going to be certain areas where you only have a few inches to deal with, but it's a weakness in your thermal barrier, and you need to address it. And there, in that scenario, you might be reaching towards a higher R value insulator. So a concept that is important is effective R value of assemblies. So you have insulation that's in a wall, but you also have a lot of other components in that wall. So you have your drywall, and you have your insulation, and you have your studs, and you have your exterior sheeting, and then you have your exterior siding, or maybe you have some exterior insulation. And the effective R value of a wall is the total of the R value of all those assembly pieces. And it's important when looking at that cross section to think also about differences within that cross section. So if we're looking at a wall, you've got, see if I can bring it up. So looking at a wall, you've got 2x4s in the wall, or 2x6s in the wall, and then you have insulation in between them. And so if you're looking across the insulation, you have the effective R value is the R value of that insulation, but then you also have 2x4s, and wood's R value is about R1 per inch. And so you have to average that R value over the entire assembly to get the effective R value of the wall as a whole. And this is important because effective R value is what we're looking for when we're looking at increasing the thermal performance of our homes. So how much insulation is enough? How many R's do we need? So this is a picture that shows the BC building code minimums, and you can see that it's very detailed. Every different aspect of the home has a minimum R value, depending on your ceiling type, depending on whether your wall is an exterior wall or a wall into your garage, your foundation. They all have different minimums. But if we're talking about taking home energy retrofit seriously, we're not talking about achieving minimums usually. We're looking towards getting to net zero. We're trying to move in the direction of which the new home building code is going, which is net zero by 2032. And so here's a map of Canada with recommendations for R values for different climate zones. And you can see we're in climate zone 6. And you can see that it shows recommended R values for the top one's your roof. So a range, 60 to 100, and then your walls, and then your below grade walls, and then your floor or your slab. So this provides a good reference in terms of when you're initially thinking, okay, what's serious R value here? What am I actually looking at? But it doesn't give you your exact number. It gives you, a pretty broad range there. And there are more insulation isn't always better. So there are economic cost insulation. So are you just wasting money, or is this actually adding to your thermal performance of your home? And there are also environmental costs of insulation. So there's diminishing returns there that can actually turn negative, both economically and environmentally, if you add too much insulation. So you're trying to find a sweet spot there. So the best way to find that sweet spot is to use computer modeling to model the components of your home. So we talked about this in an earlier presentation around energy advisors. And basically, a computer model produces a thermal energy demand intensity for your home, and it looks at different variables such as the exterior surface area, which is basically a function of the shape of your home, the thermal performance of the envelope, its airtightness, how much solar radiation it gains, the occupational and operational heat output, so cooking and just living has a certain heat output in your home that's factored in, and then the performance of your heat recovery ventilator. So the TEDI, so step 5, which is mandatory for all new builds come 2032 in zone 6, the thermal energy demand intensity is required to be 25 kilowatt hours per meter squared per year. So again, providing a good target to move towards.
Sorry, Matt, your internet just froze there. Would you mind just repeating that slide?
Yeah, absolutely.
Sorry.
Thanks for letting me know.
No
can you still see my slides if I turn my video off? You should be able to, eh? Yeah, okay. I'll turn my video off just to reduce my internet load here. A repeat of this slide. So the best way to optimize your insulation and your efforts and money towards improving your thermal envelope is to model your home. And we talked about this earlier in previous episodes with energy advisors, but basically modeling your home takes in a bunch of variables, including exterior surface area, which is a function of the shape of your house, the thermal transmittance of building envelope and its components, how airtight it is, the solar radiation that it gains, the heat produced through occupation and operation, and then the quality of your heat recovery ventilator. And by modeling this, it allows you to better optimize where you're putting your time and resources. So should I put more roofing insulation on, or should I put more slab insulation on? Should I spend my money on windows, or should I spend my money on an HRV? Modeling helps you dial in where your money and time is best spent. And for step code 5, which is mandatory for all new builds come 2032, for zone 6, which we're in, homes need to be modeled to consume less than or equal to 25 kilowatt hours per meter squared per year. So if you're undertaking home energy retrofits, that's a good target to be swinging for. So this is sort of a visual representation of how you can, starting in zone 6, the different pathways to getting your thermal energy demand intensity. And you can see the different component parts of your home there at the top, and then you can see different routes through it, leading to different intensities of operation. This one is an example of just one example picked out of that for zone 6. And you can see 3 roads to getting to a TEDI of very good, sub 15. So that's getting into passive house territory. And so the orange route, you have very good insulation on your walls, but you have poor quality windows. And you can still, through a good HRV and good air sealing, you can still end up with a very good TEDI. Or perhaps you spend less money on your installation, retrofitting your installation, but you spend more on your windows. So there's a better performing windows in the green, and they can still end up in a very good spot. And even the blue line, which is very poor performing walls, depending, and then very good windows, can lead to a good outcome too. So this just kind of shows you the different routes to your goal and how modeling can help you navigate that in the most effective way. Another way to assess how much insulation you need, one is to use an infrared camera. So we're going to have one of these available at the Roslyn Library for lending. Margot's had to trying it out, and it's going to allow you to go around your home and look at different parts of your thermal envelope, your walls, your ceilings, your doors, your windows, and it's going to show you where you're losing the most heat. So it's going to allow you to target your efforts towards those. Another helpful thing to helping you determine where to put your efforts is an EnerGuide assessment. So again, we went over this previously, but having an energy advisor in your home to evaluate it and do the modeling produces a report, and that report gives recommendations on where you can augment your thermal envelope and what that looks like in terms of an energy payoff. So when looking at insulation retrofits, there's 5 critical considerations to keep in mind. One is the cost efficiency. One is the constructability, so the relative ease or lack thereof of different approaches. Excuse me. The relative air tightness of different assemblies, moisture durability of different assemblies, and then the environmental impact of different assemblies and their life cycle impact. So I'm going to talk about a few of these, go into deeper detail about a few of these. So here's a graph of the cost effectiveness of different insulation types. I pulled these numbers, these are off Home Depot, except for spray foam, which I pulled off a contractor's website, but everything else is just off Home Depot. And then it's $ per square foot to an R rating of R20. So you can see that there's a huge difference here in cost for insulation. This difference is important to keep in mind, but it also brings you into constructability, because certain insulation types are going to require more labor. They're going to be harder to install, and so even if the insulation itself is cheaper, the whole process might be more expensive. There are also parts of your home where you're going to need a higher R value insulation. So you're going to have to go into some of these more expensive installations for certain details. But there are lots of areas, you know, cellulose in your attic is, you know, very inexpensive, and it's very easy to do, and it's a good option. So it's a good variable to keep in mind for sure. Another one that gets sort of more into the weeds with building science, but is something to think about and something to be aware of, is that air tightness is very important when we're designing these building assemblies. Vapor barriers relative to thermal insulation has a significant impact on long-term durability of that assembly. And so understanding what materials are vapor open, what materials are vapor closed, and where those are relative to the warm spaces in your home or in your assembly and the air barrier is very important detail. So something to keep in mind, something to do a lot of homework on, or consult a professional. Another aspect to keep in mind is the sustainability. So particularly pertinent right now is the carbon footprint of different installations. You can see here that there's a wide range from large emitters, such as XPS is that blue styrofoam board that you see. You can see that, you know, that's far and away the largest emitter, you know, all the way down to big carbon sinks, straw bale. So again, there's constructability factors, there's cost factors, there's air barrier factors and durability factors, but this should also be a factor that you look at, and trying to use the most sustainable product you can for the job, given all those different factors, is an important thing to do when we're looking at the life cycle footprint of our homes. So looking at one of the most common and the easiest retrofits to your thermal envelope is to increase the insulation in your attic. So this picture on your right shows you, it's basically a detail of your attic. So you've got your ceiling, hopefully there's an air barrier. You've got your rafter baffles, which are allowing airflow through your ceiling. You've got insulation plugs to ensure that insulation isn't flowing out of your ceiling and into your soffits. Hopefully existing insulation, and then your top of insulation on top of that. So this can be done blown in cellulose or blown in fiberglass. Some pros to this is obviously increase your R value, and you can increase your, if you have an attic like this, there's a lot of room to increase your R value. By spraying it in, you're getting uniform coverage. So instead of dealing with bats where you're lining them up and there's a lot of room for human air there, spraying it in gets a nice sort of uniform blanket duvet over top of your attic. And this approach is very easy. This is a case of beer and some friends on the weekend, and it is very affordable. Some drawbacks to this approach is it depends on the shape of your attic and your ceiling. A vaulted ceiling or flat roof, you can't spray this into. And, you know, depending on the exact shape, sometimes you can't get into your attic. So that's definitely something that can hinder this approach. And another one is R value at the edge. So cellulose doesn't have a very high R value per inch. And as we get towards the heel of the truss where it meets the top plate of the wall, you know, you're down to 6 inches or so. And so you might have to think about using a different insulation along that edge plate in order to increase the R value of that specific weak spot in the thermal envelope. Some considerations when doing this is that you'll want to address the air tightness issues in your ceiling prior to doing this, which we talked about in the previous talk. If you don't do that and you blow this in first, you're not getting back to those air tightness issues. And another one is those rafter baffles are critically important to install. If you don't install those before you blow this in, you're going to end up with a lot of insulation in your soffit and your roof is not going to breathe properly. Which leads us to a question that came up last talk about ice damming and the causes of it and how to address it. So ice dam, Roslyn, I wanted to get some pictures of this, but Roslyn has some beautiful ice dams on the roofs. Unfortunately, they're not good for your house. And basically what happens is that heat escapes your ceiling, goes up onto your roof, melts the snow melts and drains down your roof. And as it gets towards the edge of your house and outside your thermal envelope, it freezes up again and then creates this ice dam where water gets back in under the shingles, melts and comes into your house. They can be very damaging. So there's a few reasons for this. It's the heat loss, but air barrier is a huge function of this. So you want to address your air barrier to address this problem. You want to top up your insulation to address this problem. And you also want to look at mechanical systems in your ceiling. So pot lights are one example that often get overlooked, but pot lights are notorious weaknesses in both thermal and air barriers. And older ones pump out a lot of heat. And so if you have this problem and you have pot lights in the ceiling, that's something to look into and upgrade to LED lights. So reducing the heat, the second step is to ensure ventilation. So no matter what you do, there's going to be some heat loss through your ceiling into your roof. But if you have a properly ventilated roof, you have a nice constant flow of cold air, particularly on days like today, that are coming in underneath your soffit, running up along the underside of your roof sheeting, and then out ridge vents, hood vents, and turbine vents. So you want to ensure this whole pathway is clear. So you want to look at your soffits and make sure those are clear. And you also want to look at the ridge vents and the hood vents and turbine vents and make sure they're operable. And again, I mentioned this before, but before you put in any blown in insulation on top of the existing stuff, you want to install those rafter baffles to ensure that this pathway remains open. There was also a question from the last talk about radiant foil. This is an excerpt from Natural Resource Canada documents that basically says, don't do it. Through my research on this, just in the last week, we see a lot of this in the southern states used to keep heat out. So it's trying to keep solar radiation out of your house. The use to keep heat in has a lot of problems with it and isn't usually supported by solid science. And it also introduces some issues with vapor transfusion, and you have vapor coming through your ceiling, and if it's hitting this foil and cooling on the outside of the insulation, you get moisture problems into your insulation. So the recommendation of Natural Resource Canada is put your money elsewhere. There are many different approaches to take to improving the thermal performance of your roof. These are usually involve deeper retrofits. Not going to cover them here, but those documents I referenced earlier do a great job of walking you through all the options. So another insulation retrofit is to upgrade the insulation in your walls. One of these approaches is against using cellulose. This time it's called dense pack cellulose, and it basically involves cutting a hole in between every stud in the interior, or it can be the exterior of your house, and blowing in this insulation. If you already have insulation in there, there's a problem. I think there's a lot of older Roslyn homes that have lack of insulation, or really old degraded insulation that's only performing, you know, half the wall sort of thing. So using that thermal camera that we have available at the library, you can go around and assess this and see if this is an option that might work for you. Because it's dense packed, it improves the air tightness of your assembly, it improves the R value of your assembly, and again, it's another relatively easy, you've got some drywalling and some painting to do afterwards, but relatively low impact and cheap approach to improving your thermal performance. Some drawbacks is that it's not getting you to a real high R value. So this isn't getting towards net zero. It can be improvement, but we're not all the way there. And there's problems, things to pay attention to in terms of imperfect coverage. So you have wires and different wood members running through a wall can impede your ability to get cellulose into different areas uniformly. So something you want to pay close attention to when you're doing this. Some considerations I just mentioned, sort of ensure appropriate density and uniformity. And you want to think about how big your retrofit is. If you're looking at doing other things like siding or windows, then this might not be worth your time and money. You might want to just put your energy into exterior insulation. So something to keep in mind. Again, there's great illustrative guides walking you through the other deeper energy retrofit options. They're incredibly user-friendly, and if you're curious, are a great resource to learn more. There's also your below grade thermal envelope, so your foundation walls and slabs. These get trickier as you're dealing with moisture issues often, and you can be dealing with very different foundations. So this is getting a bit out of the DIY range, unless you want to do a lot of homework around it and really figure it out. The pros, so insulation that can go on the inside, and that you want that to be closed cell, vapor impermeable, so that you're not getting any water through there and condensation issues. If you're doing the exterior and digging out the exterior foundation, you can use vapor open products such as Roxol. So you're going to improve your R value, you're going to improve your air tightness, and it gives you an opportunity to address any seasonal creeks you have running through your basements. So by opening things up, you can do the mitigation to address that kind of stuff and improve the longevity of your home. Some key considerations are your type of your foundation, what kind of condition it is. Is it going to be able to withstand you out there with an excavator pulling up the dirt around it? The use of your basement is another important one. There's a lot of quote unquote basements in Roslyn that go, from 5 feet to 0 and aren't really used. So consider whether or not your basement needs to be part of your thermal envelope. Can you just insulate the floor instead of insulating the foundations and the slab? And it is a costly, once you're getting excavators in there and getting into some of these vapor closed installations like XPS, prices start to rise. So something to keep in mind. All right, so there's also some very nice rebates for insulation. So looking at the retrofit I talked about there with the attic blown in cellulose. This is a Fortis rebate giving 2 cents per square foot per R value with a minimum of R12 up to $900. And then you pair this with the City of Roslyn's rebates. which match it up to $500, and you're virtually looking at free installation. I called Maglios today. You buy your installation from them. They give you the blower machine for free. You know, you do a little bit of research and call some friends, and you can make a big impact on the thermal performance of your home in a hurry. All right, on to windows. So windows are another, looking at this graph, are another important component in our thermal envelope and something to consider when we're trying to increase its efficiency. In Canada, it counts for about 25% of heat loss in the typical home. As we improve the thermal performance of the other components of our house, or the thermal envelope, this only increases, the importance of windows only increases. So we're working our way up to the top of the energy pyramid, but it's something to consider when you get there, for sure. So first question is asked is, do I need new windows? So you want to start by assessing their condition. Things such as fogging between the glazing, condensation issues. My in-laws taught my kids how to do this on our windows yesterday, which is great fun. And rotting issues. So often when you have condensation issues, you have that water draining inside the home, getting into the window casement and the window frame and rotting it out in a hurry. So you want to have a look at those things. Another thing to assess is the performance. So just how old are your windows? We've got some of those old double slide or single panes, which you're not improving the thermal performance of those. So those are definitely a replacement. And older double panes should be replaced as well. And keep this in context of your retrofit plan. So windows aren't cheap. They are an involved process, and so you want to look at your whole approach and see if they fit into your budget and to your plan. Another option is to repair them. So there are some repairs that can be done on windows. If you're not ready to replace them yet, you can improve their air tightness by caulking the trim and the glazing. You can insulate, so you can pull off the trim and better insulate the shim spaces, which is the space between your window and your rough stud opening of your wall. And you can replace such that if it's an operable window, you can replace things like the hardware and the weather stripping, which can make a big impact on the air tightness of the window. There are also ways to improve the thermal performance. So that classic heat shrink glazing is basically like cellophane that you tape to your window frame and then use a blow dryer to tighten it up. Not the most aesthetically pleasing thing, but can be a big help in the short term. And some windows, there is the potential to replace the glazing, which is something worth considering. So here's a table showing so the different types of window materials and sort of an evaluation of the aesthetics and the performance considerations and the cost considerations when you're looking at these different windows. One thing to keep in mind around performance cost is that they're all going to have classifications of their own. So you can get, you know, really good vinyl windows, which are going to be more expensive than a cheap wood window. And so the relative cost is relative to just how good a window you get within each type. A few things to consider or think about. Vinyl windows are banned in a lot of European countries because of environmental and health concerns. So something to think about. They're very popular here. They're usually the cheapest option to get. That's something to think about. Wood windows are very good windows. They're repairable. They're made from a renewable natural resource, and they often perform very well, but they do require maintenance. And if you're not willing to invest in that maintenance, then you're going to lose that quality, and those windows are going to deteriorate quickly, and you're going to be out a lot of money in a hurry. The cream of the crop tends to be the clad wood. So either fiberglass clad or aluminum clad. That eliminates a lot of those maintenance issues, provides the highest aesthetic value and options, and also the highest performance, but it comes at a cost. You're paying for these windows. There are a number of design considerations to keep in mind when you're thinking about windows. So windows let sun in, which time of the year you want, and they let heat out. So there's a trade-off there. This table I found shocking, which is, just important to keep in mind. So we're looking at percent window coverage of a wall, the R value of that window, and its effect on the overall thermal performance of that wall. And the original wall R value is 50. And so if you have 2% of the window, 2% of the wall covered in window, if the window is a poor performing window of an R1, you've lost half of the effective R value of that entire wall. Versus if you get into an R8 window at 2% coverage, you've only lost 10%. So the impact of a weakness within your thermal envelope, and it can be a very small weakness, goes an impressive long way. So something to consider. Another thing to think about, which is counterintuitive for a lot of people, is that one bigger is better than two small. So one of the main weaknesses within a window assembly is the frame of it and the frame's interface with the home. And so if you're thinking about putting in new windows or putting, if you can put two windows into one, you reduce that linear foot, the linear feet of frame and interface, and you improve the thermal performance of the overall unit, achieving the same amount of glazing. Another important consideration is where are your windows? So all windows on the north side of your house are going to be net losses. You're not getting any energy in from them. They're all going to be losing energy. So try to reduce those as much as possible. There's going to be some building code requirements that might need a window on the north, but if you don't need it, think about it, make it smaller, get rid of it altogether. And then your south windows, think about, a big thing to think about is the coverage of them. So in the winter, the sun's lower in the sky and you want that sun coming in and heating up your house and getting that solar gain, but you do not want that sun coming in the summer. So appropriately shading those windows in the summer with appropriate eave lengths is a very important consideration when you're thinking about window design. Finally, looking at operability. So operable windows are going to be less tight than fixed windows. Windows that you can open close are going to be less tight than windows that you can't. And then there's a range of air tightness within operable windows, with casement and awning being more airtight than hung or sliding windows. So think about what you need there. And also, you've just installed the top of the line heat recovery ventilator, which is changing the air in your home 10 times a day. How much do you need operable windows? You might still want some. Do you still need as many? Something to think about when you're pricing out your windows and going through your budget. So there are some important performance considerations as well. Gas-filled windows are, top of the line windows now. They're all going to be gas-filled. They basically reduce airflow within the glazing, which increases the thermal performance. Low E coating is sort of a reflective, transparent, metallic coating that goes on the glass that helps reflect heat back into the home, as well as reflect solar radiation away. Thermally broken frames, so basically frames that are higher performance at reducing conductive heat loss. Triple glazing is the standard now. Really, they're a 15% price increase from a double glazed, and their performance increase is significant. And if you're aiming for net zero or a highly effective envelope, triple glazing is a must. And then air tightness. Different windows are going to have different air tightnesses, like I talked about, whether they're operable or fixed. So looking at window labeling. This is an Energy Star label that you're going to see on windows when you're shopping for windows. And I just wanted to go through sort of how to read this and some of the things to think about. So Energy Star windows, if they've got an Energy Star on them, they're at least 20% better than the building code standard. So that's a good place to start. U factor is the inverse of R value. So it's sometimes a bit confusing, but it actually means the lower the number, the better with windows, unlike insulation and walls. And Energy Star gets anything under 1.22 U factor. Solar heat gain coefficient is another thing you'll see listed on these labels, and that's basically looking at the coating on your windows and how much sun they're radiating out versus how much energy they're letting in. This is a very important variable to think about when you're placing your windows in your home. So you want a high solar heat gain on south-facing windows if you're looking to pull in that passive solar heat in the winter. But you don't want, east and west facing windows. If you've got a long sunrise or a long sunset, those windows are a lot harder to protect with overhangs, and you can have considerable heat gain to those windows. So you want to be looking at a higher SHGC for those windows. And then energy rating is it's sort of an aggregate of the other component, the other variables in a window's performance, and tries to just sort of pull it all together into one number that allows you to rate them between them. So higher number, the better. There are also a bunch of rebates to think about when you're thinking about window retrofits. So Roslyn again has a very generous rebate of $100 per tier 2 window. So a tier 2 window is an Energy Star window for a maximum of $1,000. And then you pair that with the Fortis tier 2 window rebate at $100 a pop, and you're getting $200 off your first 10 windows and $100 off your next 10. So it's not as obvious a incentive as the insulation, but it still puts a big dent. You put a big dent in your window retrofit. So yeah, something important to look into when you're planning and budgeting. Maybe this will allow you to spend a few extra dollars on the higher performance windows. All right, so that was a speedy run through of those topics. So unfortunately, we don't have, like I mentioned, we don't have any subject matter experts with us tonight. But Margot is going to flip you over and give you an option to become a panelist. I'll stop sharing my screen here. And yeah, we'll open it up to any questions from anybody. And if I or anybody else in the group can't answer them, then I'll take note of them and do some legwork to try to find you an answer.
While I just move everyone over, Matt, there is a question that was asked during your presentation by Connie, who says, our rafters are 16 on center, but the baffles are for 24. They break down into 12-inch. Is this sufficient ventilation?
Yeah, that's what my experience with installing those is that you break them in half and staple them to the underside of the sheeting. And then the only thing to keep in mind there is making sure that you block around them with insulation so that there's no gaps into your soffit when you're blowing your insulation in.
Just a compliment from Kathy saying, thanks, Matt, very informative. While people are maybe thinking of their questions, I actually had 2 questions myself, Matt. One was if you had any more information on why vinyl windows are banned for health reasons in Europe.
Yeah, so vinyl windows are short for polyvinyl chloride, I believe. And so PVC, it breaks down. I don't know the details too much, but I know that it deteriorates and releases chemicals into the air, which is a health concern. So I believe they've been outlawed in toys in at least the States. I'm not sure about Canada as well. So there's a recognized health concern around PVC. And then the chloride part is a big environmental concern, which, yeah, is a key ingredient in their manufacturing.
So please let me know in the chat if I have not given you the opportunity to be a panelist. Because you don't necessarily have to accept. I also was wondering, Matt, if we have any information on window coverings or proper window coverings, how that impacts heat.
I didn't cover that. I can do a little bit of research on that and put it in the follow-up email. I can talk about my own experience. So my house is built in '69 and has pretty big double glazed windows. And so when we moved in, we put in those baffled pull down blinds that are designed to have an R value because there's sort of two air spaces in them. And what we ran into, we increased the air tightness of our home. We started getting condensation on the windows. You pull down those insulated blinds at night, that condensation freezes, melts in the morning, and drips all onto your floor. So we've actually stopped using them. But I do know that there is a role for window coverings for sure. So I'll do a bit of research around best practices there. Does anybody?
Anecdotally, I have definitely felt like it's helped my house, but
nice.
No numbers.
Yeah, I think it probably depends on, you know, if you're not getting that condensation, then it's going to help. Like it's obviously helping with my house too, because that it's getting so cold that condensation is able to freeze. But you know, the home is a system, and you're running into another issue when you've addressed one. So yeah. Has anybody on this call had any experience doing attic blown-in insulation of their own that they'd like to share? Any tips or tricks, or anybody fall through their roofs into their living rooms?
We have, it's Connie here.
Hi, Connie.
We have blown in, but then we added extra batting up top. But this was a tip from our electrician. So from the rafters, we hung flagging tape to show the locations of the electrical lines that came through the ceiling. And then we also sealed around all of our anything, you know, wires that came up or that sort of stuff. And it made an immediate difference. But marking where your electrical stuff is really helps in the future for your electricians.
Yeah, that's a great point. Saving them digging around in a foot of insulation. There are a couple questions there. Oh no.
I do not see any more questions.
All right. Well, if nobody's got anything else, just share my screen again here. So like I said, I'll send out a follow-up email with a bunch of resources that you can put on your bedside table and read yourself to sleep over the course of the next few months. We've also got our next webinar is going to be on heat pumps, like I mentioned. So that's March 9th, 7 p.m. I actually have, yeah. So I'll send out the information on how to register for that with my follow-up email. And again, I think this will be interesting. Heat pumps, you know, pulling off our clean electricity grid are a very effective way of reducing the carbon footprint of your home. You want to pair them with energy efficiency increases so that you're not getting, you know, a massive heat pump that has environmental concerns associated with it. So you want to have a, you know, look at the different steps that we've already looked at. But this is definitely one that's, you know, gaining popularity, and there's going to be a big push to get these into homes across BC as we look to electrify and decarbonize. So yeah, I'm looking forward to that talk. All right, kept it under an hour. All right, well, if there's nothing else from anybody, thank you very much for coming. Thanks for helping out, Margot, and we'll see you in a couple weeks.
Thanks,
Thank you, everybody.